This part of the chemistry will not take very long to complete, but I want to spend a little bit of time talking about phase diagrams because phase diagrams are extremely important. A phase diagram is a plot between the temperature of a substance and the pressure of the substance. And basically it generally shows the various states depending on temperature and pressure. And so if you look at this, for example, at states of very, very low pressure, no matter what the temperature is, you're going to basically almost always have a solid. And with this one, at states of very high pressure and reasonable temperature, you're almost always going to have a liquid. But if the temperature stays below or the pressure stays below a certain amount, then you're going to have periods of significant gas. Now, a point at which all three phases are available or are present, and this dot right here represents such a point. This point right here is called a triple point. The definition of a triple point is the point at which all three phases are present: the gas phase, the solid phase, and the liquid phase. And you can see each of these lines represents certain types of phase changes. So for example, up here, this phase change is from solid to liquid. So if you're going this way, it's freezing. If you're going this way, it's melting. Here, you're changing from liquid to gas. So if you're going this way, it's vaporization. In this way, it's condensation. And down here, if you're going from solid to gas, so this way is sublimation, and this way is disposition. Now up here is something known as the critical point. And the critical point is the point at which the pressure is so high that basically a gas cannot exist. Now I realize that it shows this sort of continuing up this way, but by definition, anything above a critical point is supposed to mean that there's only, it's a pressure that's so high that a gas can't be present at that pressure for this particular substance. Now these phase diagrams look different depending on the various substances you're talking about. Now here's just such a phase diagram, and this is the phase diagram for water. And on a quiz or test, I would give you a phase diagram like this. It might not be for water, but it's like this. And I would give you certain conditions of pressure and temperature and ask you what phase the substance is in. If it's at the triple point, which is point B on this diagram, then you would say that you have liquid, solid, and gas present. If it's at point C, the critical point, you would say it's a liquid. If it's in each of those shaded areas, depending on which shaded area it is, you would give me various answers. Now also I could ask you what values represent the triple point or what values represent the critical point. And you would give me those values. The triple point is a temperature of 0.01 degrees centigrade and 0.6 kilopascals in this case. So let's take a few of these, for example. So the first one is minus 10 degrees and 50 kilopascals. So minus 10, now I didn't put how much was this, so I'm going to pretend that this is minus 20 here. But there should be a value here. I mean, you can see that this is more of a logarithmic scale, okay, than a pure linear scale. So we're going to say that minus 10 is about right here. And 50 kilopascals is going to be somewhere in the middle here. So it's going to be right about there. And that at that state, the answer would be a solid. Now 25 degrees and 90 kilopascals, okay, 25 degrees is going to be about a quarter of the way this way, and 90 is going to be right in this area right here. And so here we're going to be liquid water. 50 degrees and 40 kilopascals. Now I think I picked this one. This is right in the middle here. And 40 is right about, it's pretty close to this line. And I may have picked it specifically so that it would be on the line. And then if you think it's on the line, then the answer is liquid and gas. 80 degrees and 5 kilopascals. Okay, 80 degrees is way over here, close to the 100. And 5 is up this way, probably in this area right here, so we're in the gas area. And then the last one's minus 10 and 0.3. So minus 10 we said was right about here, and 0.3 is probably right about there. So we're at ice again. So this is an example of the kind of quiz problem that I would give you in addition to maybe one calculation, but it's almost a certainty that I would put a problem like this on a quiz or test. And the last one here is 50 degrees and 0.3. So 50 is right about there, and 0.3 is right dead in the middle there. So that's going to be a gas.